Hello, my name is Tom McLaughlin and I'll be talking about our senior design project. Our project is sponsored by Grayhill Incorporated. Grayhill Incorporated makes creative human interface devices such as a rotary switch. Rotary switches are typically found in defibrillators, sniper scopes, and radios. This is the internal workings of a rotary switch. It consists of a plastic ring with internal hills and valleys, as well as a system which the user can rotate. As the user rotates the spring and bearings, the bearing travels over the hill, compressing the spring. As the spring compresses, the torque rises and then falls. Here is a single detent. Over time, the detent will wear due to spring forces. Over a prolonged period, this will cause the spring to fail. As such, Grayhill wants us to create a device which will measure and track these changes. As such, our project will rotate the switches throughout their lifetime, measure the torque changes periodically, and then also remain autonomous to save on technicians' time.
This is a video of the switch test bank we developed testing 5 rotary switches. In this example, the torque is measured every 250 cycles. The video is run at 16 times normal speed in order to show the entire test.
The first step of testing rotary switches is what we call the lifetime test. The switches are rotated a high number of times inside the carousel unit to simulate long-term use.
Periodically, throughout the lifetime test, the torque of each switch needs to be measured. The switch needs to be ejected from the carousel in order to make this measurement. This is done by using a linear actuator, which will push the switch carrier shaft until a limit switch is pressed.
Now that the switch is in the yellow holder, its torque can be measured. The switch is rotated inside the holder. Meanwhile, a torque transducer converts the torque from the switch into an electrical signal. This data is sent to the computer for processing.
After the torque has been measured, the linear actuator retracts and the switch returns to the carousel.
The carousel then rotates to align the next switch with the transducer. The torque recording process is thus repeated for each switch.
Finally, after the torque has been recorded for each switch, the lifetime test resumes.
Grayhill desires a test bank which will rotate switches a high number of times and periodically record the torque of their detents without the use of human intervention. The system we designed utilizes a carousel to bring the switches to the transducer between lifetime tests. This design effectively and efficiently fulfills Grayhill's request.